In this lesson, we're going to learn a little about functions in C. We've already talked about the main function here. A C project can only have only one main function, but you can have lots of other functions. A function looks much like this. It has a name. Let me move this down here. It has a name like this, and it's described by a data type. Main was described as data type int, and it uses curly braces to include the code, just like that. And in name, you can have variables, if any. So I'm going to make two new functions here. I'm going to start off with this simple one. I'm going to take this code here, which gives me a nice little header, and I'm going to place it in here. Now, it's a good idea to give this a better name than we have. And I'm going to call this P1600 message. Okay. Now, I don't need any variables here. And since it doesn't need any variables, I put in the word void. And I'm not returning anything. So the data type for this particular function is also void. So I'm going to come up here, get rid of this now, and to call the function, to make it happen, I just say P1600 message, open bracket, close bracket, semicolon. That's not quite enough to make this work, because every function other than the main, when you use it, has to be defined at the top of the file, what's called a prototype. So all you do is you essentially just take this top line of your function and move it up right here. Put in a semicolon at the end, and we'll put in a message that this is a function prototype. If I've done everything correctly, I should be able to compile this now. Let's go here and let it run. Okay, as you can see, it did print out the header message just like we want it to. I'm going to do next something a little more complicated. This is a very simple function because it's not returning anything and it's not taking anything. I'm going to take this part of the code from here to here, and I'm going to play around with this and make a second function. So Control X, I'm going to come down here, say void loop void here, like this. Now, this function, I need to define the data type of sum and int. So int I comma sum. And I'm going to come up here, and I no longer need this line up here. Get rid of that, come down here. Right. And we're calling loop like this. Right. So I think I've got this all done. I need to prototype it again, Control C. Bring this up here, semicolon, function prototype. Oops. Let's compile this. See if I have any mistakes. I have some expression syntax. Extra bracket. Okay, and we'll minimize this. Go back here. And we're going to step through again. And you can see it gives exactly the same output that we had before. Wouldn't be much use if it gave me something different. Okay, so we've created two functions. This function I'm kind of unhappy with. First of all, the name's not so great. When you name functions, they should be useful names. Like, what are we actually doing here? We're summing a series. So I'm going to put it up here as well. Sum series, and this sum series. And the other thing about this, it doesn't let me do anything else here. It only lets me sum this particular series. So what I'm going to do is I'm going to alter this so it actually takes numbers. So we've got a for loop, and the thing about a for loop is it has a start, it has a limit, and it has an increment. And if I come down here and I replace 1 by start, 20 by limit, and this as I equals I plus increment, I can have this work for almost any combination I can think of, including the one I started with. So that's great, but now I need to come back here and actually tell it I wanted it to do it for 1, 20, and 5, just to make sure I've done this correctly. And up here at the top in the prototype, I have to put that information in as well. Let's build that, see if I have any typos. It worked. Perfect. So let's go here, and when I run it, it gives me the result I expect. But I can change this build it again, and get a different answer. And that's the nice thing about a function that's a little more general. It's reusable. We could use it in other programs. Here we are back at our function again. I want to show you one more thing. This function, sum series, is a little more general now, but it's still kind of restricted because when I get the answer, all it does is print it out. Maybe I just want to use that number. And what I'm going to do is down here, I would like to return the answer, which is sum. So I just say return sum. I'm not going to print that out anymore. I'm going to bring that up here and print out. Now back to this function, because it now returns something, I can't use void. Sum is an integer, So I say int some series. Let me go back up here and change this here. Int some series. And down here, because it returns something, I need to have a variable equal to this. So I'm going to call it answer, and I need to make space for answer, int answer, and right here I'm going to change this to answer. So if I want to return a number, that's easy enough to do. I just have to make sure that the type of answer matches the data type for the function. And if I've got that right, this should work for me. So let's try that. Hey, so that worked. Let's come here. Let's run. And it's identical again. So we seem to have done that properly. Okay, so we can create very general functions. And the thing about functions is you often quite often will reuse them again when you build other projects. So typically you want to keep your functions in separate files, especially if they're related. We're going to build a little library here. A library is a combination of two files. We've already seen them before, one of these library files, configureUsart.c and configureUsart.h. And that's got code that with functions that we use. In fact, this configureUsart function. So what we're going to do is we're going to create a header file, something that ends in .h, and a source file. So let's do that right now. So let's create one empty file and a second empty file. We're going to make this guy the header file. And in the header file, the major thing that you want to do is put in the function prototypes. Okay, and we're going to save this file. For now, we're going to save it in the same directory. Which I've forgotten where. Oh dear, where did I save it? Oh, I put it in here. I renamed switch without realizing it. So we're going to save this as functions.h. Not a great name for a file, but we'll use it. Right? And we're going to include that header file right here. And we don't need these things here anymore. What we need instead is to say we're going to include that library. So this is now functions.h. We're going to go and find, I don't know where that other file is. I think it's here. Here's the other file. And this is where I put the source code, these extra functions. So I take them and get them out of there, put them here. We're going to save this file as functions.c, a library file. The two files just have to have the different extensions, .c and .h. Let's save it, and we're going to add that to the source file. Now, this source file is functions, and functions, as set main, always have to be prototyped. So we have to do number include functions H. Okay, that's not the only include we have to do. This this function P1600 message uses printf, and printf is here. And printf, there's code that's necessary for it to work in configure usestart.h, so we have to copy both those to right here. And now that file is pretty much the way we want it to be. It's got the functions call that we want to call, and let me minimize that, minimize this, and we're going to compile all. Right? Okay. See what happens. Make sure that it's built all our functions. Come back here, simmer at 1, and when we run it, see if it generates any error messages. And voila, we get the same answer. Now, a couple of things here. One about functions.h. If you were to write a program for a project, you're usually working with partners, and different people usually build different libraries, and they're always brought together. The problem right now is that this function prototype, there's not enough information to tell somebody what these functions do. So I would put some comments like prints P1600, right, or physics 1600. And for this guy, I would put down something like sum equal to equal to start plus n times increment while n less than limit. It's not a great explanation, but it will help somebody who understands what you're trying to do. In general, these guys should end in a blank line, but that's not too important here. I'm not going to compile this because these are just messages for other people to read. One last thing. If you're going to be writing a fairly complicated project, normally what you do is write a skeleton of what your program is supposed to do. And let me show you something like that. So you might have something like this. This is the skeleton that we will use on pretty much every program we start. But if you were deciding what to do, you might want to print a message. Okay? You might want to decide if A is less than B, and then print answer. Typically, what you do is you create functions. You write a skeleton of what you want to do, and for each piece, you should have just a function, or maybe several functions. And in one of those functions, there can be other functions. And that's a much easier way to write programs and to debug the pieces of the programs. The functions and programs we write won't be extremely complex, so I don't want you to get too worried about that. But functions are how professional programmers write their code. That's it for now.